Hello everybody and welcome to our video on 15b, which is the chain rule. The chain rule is probably the one of the derivative rules that you're going to use the most. Okay, and before we talk about the chain rule, we need to talk about what a composite function is. So remember from previous math courses that a composite function is either adding or subtracting or composing one function of another. Okay, we can often write complicated functions as the composite of two or more simpler functions. So for example, this function we see here, x squared plus 3x all raised to the fourth power, could be rewritten as y equals u to the 4, where u is x squared plus 3x. In other words, we could take this complicated part and call it u and raise it to the exponent 4. And then we could combine them together to say that we're evaluating g at the value determined by f of x, where g of x is x to the 4 and f of x is x squared plus 3x. All I'm saying is that we can take a complicated function and break it down into a simpler one. So let's do a little bit of practice with that. If we have a function that is the square root of x and another function that is x plus 5, then if we want to find f of g of x, that means we want to evaluate f at g of x. So first we have to find g of x, which in this case is x plus 5, and then we have to sub this part into f of x for x. So it gives us the root of x plus 5. This is the new x for here. But if we evaluate g of f of x, then first we have to evaluate f of x, which is root of x, and then we have to sub it in for x in g of x. And notice that f of g of x and g of f of x are not equal. Sometimes they are, but most often they are not. Okay, and we can compose and decompose functions in different ways. Okay, what I like to think of is g of x is the inside function and f of x is the outside function. So for example, if I wanted to break this function down into two smaller functions, I could call all of this part that's underneath, or I could start by calling just the x part g of x, the x squared part. And f of x would be the x plus 6. So I could say that I can put x squared in for x in this expression and get f of g of x is x squared plus 6. Another way to think of this is to take everything under the square root and call that g of x, the inside function, and make this square root the outside function. So when I combine them together, if I was to sub x squared plus 6 in where I see x here, I would go back to this original composite function. Likewise, I could take this function here. I could call the inside part 5x minus 6 and the outside part the raising something to the exponent 8. Okay, so I can name them this way, and then if I compose them, if I substitute this function in where I see x, then f of g of x is 5x plus 6 all raised to the exponent 8. Okay, and it's best when you make the inside function a little bit more little bit simpler and the outside function more complex. So like a square root or an exponent is more complex than just a linear function or a squared function. I should say quadratic function. In calculus, it's important that we're able to decompose a composite function so we can determine the derivative.